Well, I would like to welcome you all to another episode of Booth Ross and the Joy of Mathing. Today we're doing modeling sinusoidal waves. That just means that these are going to be waves that are either sine or cosine functions. In fact, first thing I want us to learn is when you model a sinusoidal function or any of the sine or cosine graphs, what you need to do is look at your your y-axis, which is where your y-intercept will be. Okay, so look at the y-axis and note where the graph is starting. Okay, so the reason I say that is because remember, if you look at the sine function versus the cosine function from a couple lessons ago, sine is always going to start on the midline. Or at least our parent function always starts in the midline. Cosine, the parent function will always start at the maximum. Okay, so if you find that your graph is starting on the y-axis at the midline, it's going to be a whole lot easier for you to write a sine graph. If you find that your function is either at the max or the min, it's going to be a whole lot easier for you if you just write a cosine equation. Okay? In fact, I'm not going to try to trick you. I would never put a horizontal shift into any of these. In fact, I'm going to show you how to do every single problem today with no horizontal shift. So since there's no horizontal shift, in fact, this one, notice, is starting on the midline, right on the where I highlighted. That means we're going to be using a sine for this graph. So I'm going to go ahead and just write our general equation without a horizontal shift. So our general equation will be y equals a times sine of bx plus k. At this point, I want to go ahead and review what each part means. So this a right here is your vertical stretch or compression. That is going to be determined right here by our, what we call the amplitude. Okay, so A is essentially our amplitude. A is actually, the absolute value of A is our amplitude. Now, if your A is negative, that just means your graph is instead going to go down and then up. So that's the only difference. So I showed you a positive sine function and a positive cosine function. A negative sine function would look like this. Let me put it on this side. So negative would look like that. Ooh, that looks ugly. It's okay. A negative cosine would look like this, where it's starting at the minimum. Okay? So just like that. So, but the A, to make things easier, is essentially your amplitude. Your K, let's go to K first. Our K is our vertical shift. So that's how far up and down our graph is going to be shifted, which is going to affect the midline. Because if you shift your graph up 1, up 2, up 3, whatever it may be, or down 1, 2, or 3, that's going to be our midline. So K is actually just directly going to be where the midline is. Now let's go to B. B is going to be, you use B to find your period. And your period is always 2 pi over B. I'm just going to abbreviate that P instead of per. Okay, so your period is always 2 pi divided by B. So I don't know if you noticed, but there are 3 key features of a graph we always need to find. We need to find our amplitude, our midline, and our period. Now, before we can find all that information, one thing to note about the period. Because the period's not what we're going to put in here, we want the B, we need to solve this equation for B. So I'm going to go ahead and multiply both sides by B. So B times P equals 2 pi, and then divide by P to find our B. So B, notice, is actually just 2 pi over P, or if you went back to what I originally wrote, literally all you have to do is swap those 2 places. So B is 2 pi over P, or the period. Okay, so let's go ahead and find that information. An easy way that I use to help myself remember what information we need is MAP. So midline, amplitude, period. You do what you want though. Okay, so midline on sine graphs should be the easiest thing to find because that's wherever you're starting. So we're starting at 1. So our midline is at 1. Amplitude should be pretty easy. Our maximum is at 3. You're just finding the distance. It's half the distance of the whole graph, like half the vertical distance of the whole graph. You can do that by just subtracting your midline from your maximum, or just counting in this case. There will be some problems where it gets harder that I'll show you later on. Period, this one's probably the hardest for people to figure out, but the period, the easiest way to do that is go to where you start and then kind of highlight or just take note of where a full cycle is. So the sine function right here, this is one full cycle. It has the minimum and the maximum, and it begins and ends in the same spot. If you look, so we started at 0, but we're going all the way across to 2 pi. That 2 pi is our period. So now we have all the information we need to go ahead and fill everything in. So our amplitude, which we did in blue, is the 2. So I'm going to go ahead and put y is equal to 2. Now we do need to make sure, is it a positive or negative? Well, since the graph is going up to the maximum first, it's positive 2. Then we've got our sine. To find our b, this is where a little work has to come in. So we're going to take that period, and remember our b is 2 pi divided by our period, so 2 pi divided by 2 pi. Well, 2 pi divided by 2 pi is literally just 1. So we got a 1x, or you can just leave it as x. And then last but not least, we've got this k right here, our midline. Our midline in this case is 1, so I just put a little plus 1. And that is the answer. So let's go ahead and do another one. This second one will probably go a lot faster than that first one did. Okay, so remember, first thing I'd say is go ahead and highlight where your y-axis is to find your y-intercept. Determine where that y-intercept is. Is it at the midline, max, or min? So in this case, it's at the minimum. So remember, max or min is going to be cosine. I'll go ahead and write my general equation. And then I'm going to take note of all the things I need to find. So I need to map this out. So I need to find my midline, my amplitude, and my period. So for a lot of these midline problems, it's going to be pretty easy for you to just kind of like guesstimate where it is. But I'm going to show you a trick. So our max is at 1, our minimum is at -5. So midline is directly in the middle, meaning you can just average those numbers or add them together and divide by 2. So you get -4/2, which is -2. And I'm going to go ahead and just put a little dot there so we remember where that is. Okay, next thing we have is our amplitude. Amplitude, I showed you this trick, so that's at -2. You're just finding that distance. The distance you can find by subtracting them. So 1 minus -2, which is positive, wow, positive, just a 3. 1 minus -2 is 3. I'm really good at math. Okay, our period, you just go from that beginning point and then you just kind of highlight where a full cycle. So cosine, since it starts at the minimum, you go just to the next place where we hit the minimum. So that's one full cycle. And then we just look at the horizontal distance. So we're going from 0 all the way to 4 pi. That's what this is right here. So our period is 4 pi. Let's fill everything in. So first thing we need is the amplitude. That's right here. So we've got y equals 3. Let's determine if it is a positive or -3. Since we're starting at the minimum, we're going to go ahead and put a -3, because remember, if you start at the minimum, you start at negative. Max means you're positive. So we got -3 cosine. Let's find our b. So the b, remember, is just always 2 pi divided by whatever the period is. So we've got our period is 4 pi, and 2 pi divided by 4 pi is 1/2. So we got a half x. And then last but not least, we just need our midline. And so you just kind of attach the midline at the end, so -2. And there's your answer.